So we have 1, 2, 3, 4 different problems in this one problem. And what we're trying to do is we're trying to figure out, fill this table in, trying to find specific volume and what the phase is. All right. So which one did we do? We did A, right? Because I think Brendan wanted to do that one first. A and C. So let's review these. So A, temperature was negative 12 degrees C, and the pressure was 320 kilopascals. So what did we do? We found P sat to be 185 at that negative 12, and we compared P to P sat. So P was greater than P sat, so we automatically know we're compressed liquid. Okay, that's the rule. Then, your specific volume, anytime you're a liquid, you can always, almost pretty much 99% of the time, assume all the F values. So VF, HF, SF, that's fine. Okay? Questions on that purple one? Okay, then we did C. I think C was stated as a saturated vapor. So we're saturated vapor, so P is equal to P sat, and T is equal to T sat, and your specific volume is going to be equal to VG, because you're right on that line. So you can go up and find in your charts 550, and then figure out what your temperature is, which is T sat, and what your specific volume is. Yes, Dick?
And just on number part A.
Yep.
0.00075, we get that from the table also.
Yes. This VF comes right off the table. Yep. Yep. All right. We might as well just do B now, right? So part B. Part B, temperature 30 degrees C, right? Yep. And ooh, this is a good transition. Specific volume was 0.0065 meters cubed per kilogram. Okay, so from table A11, and we'll look this up after we do it. Hopefully it's the right table, I think it is. VF 0.000841 meters cubed per kilogram, and VG is 0.026622 meters cubed per kilogram. So when we draw this vapor dome, what do we find out based on those?
Where V is.
Yep. Yeah, where are we? In the middle. Yep. We're in the middle, so we're a mixture. And what is your P equal? And your T equal? They're all P sat and T sat, right? So this is 30 degrees, and the pressure comes out to be 771, sure, I'll round up, kilopascals. So write that down, and I'm going to open up this. I'll come back to it. It's A11, right? A11 because we're using refrigerant. Yep. And the temperature was 30. Over here, temperature's 30, and our PSAT is 771. Okay? And let me highlight that so I can zoom right in even more. Okay, so the highlighted region, our P is our PSAT, so 771, and we compared our V with VF and VG. And we found that it's in between. Cool. Questions? Okay, now we're left with part D. Any guesses where you think D is going to be? T is 60 degrees Celsius. P is 600 kPa. Using table A11, we find P sat at the temperature of 60 degrees C to be 1682.8 kilopascals. P is less than P sat. So this means we're way out here somewhere. So now we have to use table A13. That is the table used for superheating values for refrigerant. So I'm going to give you the answer. So I'm going to rewrite this again because the back of the book uses megapascals. So 600 kilopascals is 0.6 megapascal. And we find our specific volume to be this value. Oh, and we're gas, right? I can write that down. Vapor, gas, superheat. Okay, so let's go to the tables and look at this. This is a little different. So A13. So in this, you have grids of different pressures, okay? And on the left are temperatures. So we need to find 0.6 megapascal, which is right here. So here is pressure, 0.6, and our temperature was 60? Okay. So we're right here. So our specific volume is 0.041389. Is that what I had? Yeah, 139. Yeah, I just rounded. Yep. Okay. And then automatically you know your internal energy, your H, and your S. Okay. Now, anytime you're over in a superheated region or the gas, you could use the tables. For next class, we'll talk about equations. Okay? So it's up to you what you want to do for that. So, does everyone know how to do that?
That's the superheat.
This is the superheated refrigerant, 134A. Yep. I believe for water, I think it might be table A7 or 8 or something like that.